what I'd like to hear about is your the simulation part of Sven.ai. So Eric's product that Eric's been building over a number of years has a tool in there for value stream mapping, and you can assign parameters to each task in the value stream, and then I believe you can run a simulation which will actually then predict the queues that would build up at each. So talking about Kingman's law, you'll be able to say what the cycle time is for each task, what the variation is on each task, and then start a supply of units coming in, and it will predict what the build-up of queue and build-up of whip would be. I mean, that's the theory. How is that something people have been using very much with Sven? Is it? Can you explain a bit about that?
Actually, yeah, and I've added a couple of things for like lot sizing and stuff in there. Actually, for a few folks who I know are using it with, bigger, with consulting friends who use it right now. And I've been kind of teasing at this for a couple of weeks, and we're kind of finally at the point where it's coming to an end now. But what I essentially did was separated out all of the simulation and math and kind of, all of that stuff from Sven, the software, rewrote both of them, and, gave Sven a bit of a new face. So that simulator is now, if you've got a value stream map, you can take that, look at it from above, so you can see, human motion, logistics, and things like that at the same time. So you can actually it's almost like how a video game engine works now, to where you can kind of take these scenes, parameterize them, and then make them dynamic with, real world physics, queuing, and things like that built in. So yeah, you can actually kind of play out a value stream map, with a big schedule, see it from above, see the machines, and kind of see how things move. In Spend, a machine is very simplified. It's just a shape.
A block, yeah.
Yeah, but the engine itself,
Yeah.
Yep, I built the engine and we kind of talked about this with Sigma XL, but the engine itself for, anyone to use really. So any app can say, here's how this machine needs to be rendered and kind of how things need to move around on the board, so to speak. But as far as how things queue and all of that, it's just like a video game engine where the physics are always going to be the same and certified against, a NIST standard. So I've got, everything is sort of the statistical tests are all, calibrated against NIST data or the mini-tabbed worked examples, which is kind of the standard, and fully accessible and kind of redeployable to, to anyone now. So I'm basically taking all of the math, the things that essentially everyone has charged a lot of money for, and making that the thing that you can build on top of with a very thin layer. So Spend is now just one of those thin layers, but being kind of my product is still going to be the one with by far the most built into it. So yeah, absolutely. And I'm trying to think through the list of everything that you can do with the value stream map now, and I'm probably missing like 99% of it. But yeah, that is the idea. Is it takes kind of a process or a value stream as an object with everything built into it, to where you can zoom in on machine center and things like mean time to failure and things like that, and kind of again tweak parameters and then play things out. So actually do your current versus future state and watch performance play out in real time, and things like what happens if I add another shift on this machine or whatever, if I can reduce whip ahead beforehand. Basically, does my process flow better? Can I actually see that over the course of several days? Does the whip before this thing actually come down? So that's the general idea, yeah.
It's a visualization of Kingman's law. Basically.
Exactly, yeah.
The equations or Kingman's formula is sort of built into your program.
Yep. Yeah, and I've been sitting there kind of making sure, doing, running tests on it to make sure it actually, adheres to those things.